So, starting part 4, we're going to be dealing with graphing linear inequalities now. And just to give a little bit of background as to what they're talking about here, we have slope-intercept form where y, let's say, is less than mx plus b. And then sometimes you'll see y is less than or equal to mx plus b. And let's jump over here. Y is greater than mx plus b. And y is greater or equal to mx plus b. So there are 4 inequality signs. Now, let me just go over what's happening in each one. Now, I know you've been taking a lot of notes, and unfortunately, that's the nature of the game here. There's lots of stuff going on. So, generally, these are all a graph of y equals mx plus b. So if we have, let's say, y equals 2x plus 2, let's say, our slope is 2 over 1, our y-intercept is 2. So let's put our y-intercept in here. There's our y-intercept. And that's going to be for all of these. And just sketch these in. Now, interestingly, this line is the same for all of these inequalities. The only difference is, and let's just plot this first one, y is equal to 2x plus 2, so it's 2 over 1. So let's use this one here. So we're going to go over 1 up. Let's do that. Over 1 up 2. So this line is going to look like so here, more or less. Because it's greater than or equal to. So that's going to be the shape of every line for this equation. But in the inequality form, if it's equal to it, as well as greater than, as we see here, it's going to be that same line, over 1 up 2. Now, how about if it's only greater than? Well, instead of having a solid line here, we're going to have a dotted line. Because the values along this line aren't included in the set, and that applies for this one as well. Over 1 up 2, about there. So if it's only greater than or less than, then it's a dotted line. If it's greater than or equal to or less than or equal to, it's a solid line. So this is what they're talking about here. Now, the next part of this is, which part do you shade? Because here, this is not just points along a line, but it's a region that is shaded. And this is what I found to be true. If you have a positive y, which is this, that's what this is up here. This is a positive y. Then the upper part here is shaded. So it's shaded up here. If you have a less than, y is less than something, then you shade under the line. And that's the major differences. So again, you're thinking of what would the line be if it's equal. If it's greater than or less than, the line is dotted. And if it's y is greater than, you shade above the line. If y is less, you shade below the line. Now, there's other ways to do it that I'm sure they're going to show us, but this is just some background information. So let's go on. Now, they're talking about a test point where we put a value in there and see if, let's say, the origin makes it true. If by putting in the test point 0, 0, if your statement is true as you read it, then you shade in that area where 0, 0 is a point. If it's not true, you're going to shade on the other side. And for some reason, I see we have gone backwards here quite a bit. Let's see if we can get to where we want to go. Okay, there we go. So, let's work on this one. So, graph the half plane that satisfies the inequality. So here apparently what they did is they made that x and y intercept t-chart to get your line. So if x is 0, y is 6. If y is 0, x is 3. And these are our points. And since it's also equal to, we have the graph that's a solid line. Now, where are we going to shade? Now, I would personally solve for y. So, following what I said, y is less than or equal. So we're going to shade under the line here. Now, using the technique that they have just mentioned, though, let's put in 0, 0, which is the origin. If I put a 0 here and a 0 there, is 0 now, these become 0, this is 0, is 0 less than or equal to 6? Yes. So the origin is in the shaded point. So that is your test point. If you say, and you place a test point and it makes your statement true, then that's the part that is shaded. If by putting in there 0, 0 made this false, then you'd have to shade the other side. But we're using the test point and this general principle that if you have a positive y is less, you shade under the line. And let's clear that up and move on. And they're using 0, 0, and it's a true statement, so they're shading this portion. Okay, let's graph this now, and you'll be putting this in your notes as well. So we have y is greater than 2x. Now remember, our slope is over 1, and we have our y-intercept, since there isn't any, is 0. So we're going to graph that. So we have a dot there at the origin. Now our slope is 2 over 1, so we're going to go over 1 and then up 2. But remember now, since this is only an inequality and there's no equal, this is going to be a dotted line. Now we have to determine where do we shade it. Well, if you use that technique of a positive y is greater, I'm saying we shade it up here. Now, let's try a test point. Let's say this point right here, which is 0, 0, comma 2. Now, we put that into this equation where this is 2 and the x is 0, and we get then 2 is greater than 0. is this true? Then this test point that we've placed is in the shaded region. And that's another way to do it. And let's check it out here. So there's the graph, and now they've used the point -3, 0, which is also in the shaded region. So I had used this point up here. There's many that you can choose. All of these. There's an infinite number of points in here. But you want to be sure you shade on the right, correct side. Okay, let's do this one. So our equation is y is greater than 1. Now notice this is in the form of y equals b, and this is a horizontal line. So let's make a graph. And our b value is going to be 1, so right there. And remember, it's only an inequality sign, so we're going to make a dash line here. But where do we shade it? Well, again, y is greater, so we said when that's the case, we shade it above the line. And that is the correct answer. Now, if you put a point up here, and this would be, let's say, y equals 3, is 3, this would be a 3 here now, is 3 greater than 1? Yes. So this dot is in the shaded area. Okay. There's the graph, and there's the shaded area. Now, for this one, we're going to try x is less than or equal to 0. This is in the formula x equals a. So we're going to make a graph. And where is 0? Well, x equals 0 is right here, and it's going to be a vertical line. I'll have to change colors so we can see it here. Should go through the 0. And it's going to be a solid line going through 0, a little bit off. But now, where is x is less? Now, is x less than 0 on this side or on this side? Well, x is less than 0 on this side, so we're going to shade over here. And you could put a point here as -3. And is -3 less than 0? Yes, so this is the side we shade. I think these are fun and maybe a little easier than things we've been doing. So there's our graph, and notice our line coincides with the y-axis. X equals 0 is the y-axis, believe it or not. And then there's a test point. So we shade on this side. Okay, now let's do this one. They're asking us to use a calculator to do it, and we don't use calculators for this. So we'll just do it in the regular fashion. So I would suggest we solve for y. We're going to transpose this, -2x plus 7. So we're going to make a graph. Our y-intercept is 7. 1, 2, 3, 4, 6, 7. So it's a dot there. Our slope is a -2/1. So we're going to go over 1 to the left because it's negative, and then up 2. And do we use a solid line or a dotted line? A solid line. So it looks like so. Now, where do we shade it? Again, by solving for y, if y is less, we're going to shade it underneath. Now again, we could use the origin 0, 0, and if we put a 0 there, and we put a 0 there, is 0 less than or equal to 7? Yes, this is true. So the 0 as our test point is in the shaded area. Okay, well I think this wraps it up because they then go to some questions that we might take a look at. And they're going to go through a calculator, and it looks like what we had. And again, you shade under the line. And this is just another one. Putting it in this form, where would we shade it? Y is greater, above the line. There's our y-intercept, and there's our slope. And they're going to do this one for us too. If you had a graphing calculator, this is what it would look like. Okay, now these are some practice problems. I'll pause it here for a moment, but we've spent a lot of time on this one section. There are some more. If you want to do any of these, you can. And then these are all the answers. So, hopefully you're moving along, taking some good notes. We'll be having quizzes on this. Open notes quizzes.